Welcome to our final video in the material on the time value of money, chapter 4 in your textbook. And we have two important concepts here. One of them is used a lot in finance. The other one is not used so much, but they're both important concepts. And that is to find the present value of a growing perpetuity and the present value of a growing annuity. The growing perpetuity is used a lot in finance. The growing annuity is not used nearly as much, but it's used sometimes, so we want to make sure we understand it. As you know, a perpetuity is a level stream. It's a level stream of cash flows that never ends. A growing perpetuity is not a level stream of cash flows. It is a stream of cash flows that never ends, that's growing at the same rate forever and ever and ever. So let me show you what I mean here. Let's bring up the whiteboard, and let's say that we have got a cash flow at time 1. So we're standing here at time 0, and at time 1, we're going to receive $100. Okay. Now at time 2, we're going to get 3% more than $100. So we're going to get $100 times 1.03, which of course is $103. Now at time 3, we're going to get 3% more than what we got at time 2. So we're going to get $100 times 1.03 squared, which is going to be $106.09. Now, at time 4, we're going to get 3% more than we got at time 3. So we're going to get 100 times 1.03 to the third power, which is $109.27. And this is going to go on forever. Okay, so this is going to go on and on forever. Every year, we're going to get 3% more than what we got the prior year. And we want to know, how much money do I need to have at time 0 to be able to fund this? How much money do I need at time 0 so that I can take out $100 at time 1, $103 at time 2, $106.09 at time 3, $109.27 at time 4, and every single year after that, take out 3% more than the prior year and never run out of money. Always be able to do that. It sounds complicated, but it's really a very simple formula. The present value of a growing perpetuity is equal to the cash flow at time 1. And we need to subscript the time because it's not the same cash flow each year. So we need the cash flow at time 1 divided by R minus G. Now, G is the rate of growth. In this example, that was 3%. Each year we got 3% more. R is going to be our discount rate, as always. What is the rate of return we're earning on our money? And I don't believe I mentioned that yet. In this example, it's going to be 12%. So how much money do I need to set in the bank so it's earning 12%? So I can pull out 100, then I can pull out 3% more than that, then I can pull out 3% more than that, then I can pull out 3% more than that, and continue to do that forever. The money's always earning 12%, and I'll never run out of money. That's what this formula will do for me. So it's going to be the cash flow at time 1 is 100. R is going to be 12%. That's my discount rate, 0.12. G is my rate of growth. That's going to be 3% here, minus 0.03. So it's basically 100 divided by 0.09. And that's going to be equal to $1,111.11. It turns out to be a repeating 1 is what it is. So if I have $1,111.11 and I put it in the bank today, earning 12%, I can pull out $100, then 103, then 106.09, then 109.27. And each year I can pull out 3% more than I did the prior year, and I'll never run out of money. I'll always have enough. Okay. But if I start out with less than $1,111.11, then at some point in time, I'll run out of money. It may not be soon. It may not be for 1,000 years from now, but at some point in time, I'm going to run out of money if I start out with less than that. So that's the present value of a growing perpetuity. Now, if you wonder why do we use that a lot in finance, well, gee whiz, there's a whole lot of situations where we have projects that we have that. Let's say we want to make a new product, and we think the sales of that product are going to grow, well, like this. They're going to grow at 3% per year. For how long? For as far as the eye can see. It doesn't have to literally be forever, okay? Because it's going to give you practically the same answer if you say 100 years or 1,000 years or something like that. So we use this for something like that. So if we say, hey, the revenues are going to grow forever, okay, at 3% per year, what's the present value of the revenues? This is what the way you would go ahead and do with something like that. Or suppose you own a stock and the stock is paying a dividend, and the dividend is going to be $100 a year from now, right? You have a few shares of it, and you're going to get a $100 dividend, and then the dividend you expect to be growing by 3% per year forever. This would be exactly what you would do there to value the present, get the present value of those dividends. So there's a lot of things in there. And I want to emphasize too, something doesn't literally have to be growing at the same rate every year forever. It can just be for a very long time, and we don't know exactly how long that time is going to be, as far into the future as we can see. And we may say, hey, I don't know that it's going to grow the same rate every year, but yeah, I don't know what the rate of growth is going to be. So I make an assumption, okay, about what I think it's going to be every single year. And so we would use it for something like that. Now, you may have noticed a few things about this formula. First of all, as R and G get closer together, the number in the denominator gets smaller. As the number in the denominator gets smaller, the present value gets bigger. And in fact, if R and G are equal to each other, then this number in the denominator is so small, it's 0, and the present value becomes infinite. In fact, you're really not even allowed to do that. You can't divide by 0. I think there's like 6 states or something like that, they put you in jail for dividing by 0. So you really don't want to do that. So what it tells us is that there's not enough money to be able to provide a growing perpetuity if the growth rate is equal to or greater than the discount rate. Okay, so the discount rate, R, has to be greater than the growth rate in order to be able to fund this growing perpetuity. Okay, so that's one of the first rules. The second thing we want to take a look at is what happens if the growth rate is 0. Well, if the growth rate is 0, then you've got $100, $100, $100, $100. You've just got a regular old perpetuity. And guess what? The present value of a perpetuity is equal to the cash flow divided by the discount rate. It's the same formula we've got here. When the growth rate is 0, the present value of a growing perpetuity is the cash flow. It's the same every single time, divided by the discount rate minus zeros, divided by the discount rate. So our formula for the present value of a perpetuity is the same thing as our formula for the present value of a growing perpetuity, where the growth rate is 0. Okay. So we now know how to do the present value of a growing perpetuity. How do you do the present value of a growing annuity? Well, a growing annuity works just like a growing perpetuity, except it stops at some point in time. So let's suppose we've got this exact same situation. We get $100 at time 1, and it's growing at 3% every year. But this time, instead of saying it goes on forever, let's say the last time you get money is at year 10, and it stops at year 10. No more cash flows after 10 years. That's a growing annuity. It's growing at, the cash flows are going at 3% per year, but only for 10 years. Now the formula is a little bit more complex. And unfortunately, Excel doesn't have either the growing perpetuity formula or the growing annuity formula already programmed in. Now, the growing perpetuity formula is kind of easy, so that's not going to be a problem if that's not already programmed into Excel. But the growing annuity formula is a little bit more complex. However, I got good news for you. I've written up a growing annuity formula, and I'm going to show you a shortcut way of doing it as well in just a few minutes. But let's see what the formula looks like. The present value of a growing annuity is equal to the cash flow at time 1 times 1 over R minus G minus 1 over R minus G times 1 plus G over 1 plus R raised to the T power. Okay, so G is my growth rate, which again is 3% that we put in there. R is the discount rate, which was 12%. The cash flow at time 1 was $100. And T is going to be how many times we get cash flows. It's going to be a different cash flow each time, but how many times are we getting those cash flows? We said it's going to be 10 times. So I've got all the numbers I need to find the present value of a growing annuity. Well, clearly it's got to be less than $1,111 because $1,111 will give you a growing perpetuity. It'll go forever. Okay, we only need it for 10 years. So it's going to be something less than that. So how do we do? I mean, yeah, obviously you could do this by hand, but we don't want to do any of this stuff by hand. Okay, and we've got Excel. Let's go ahead and use it. So let's go to Excel, and there's I'm going to take you to a spreadsheet that I put together that is available to you that I think I titled "Growing Annuity Formula in Excel." So let's go there and take a look at it. Okay, and make sure I can find it. Here we go. Okay, so what I've done is I've set up, this is the same problem we're dealing with here, right? Where we're saying the discount rate is 12%. These are all our variables. The growth rate is 3%. The number of compounding periods is 10. The cash flow at time 1 is $100. And here, what I've done is I've just typed out that growing annuity formula. I'm saying the cash flow at time 1 times 1 over R minus G minus 1 over R minus G times 1 plus G over 1 plus R raised to the T power. Okay, so that's all I did. The hardest part of that was putting together the parentheses in the right spots. So that tells me that the present value is $630.33. If I have $630.33, I can pay out $100 at time 1, then 103, then 106.09, and so forth. But let me tell you an even easier way, in my opinion, of doing it. That worked, okay, but there's an easier way. You type in $100 here, okay? Then here you do a cell reference, okay, where you say equals, okay, and you reference that cell right there. So what you want to do here is you want to say equals, and then you click on that cell, times, okay, find my times 1.03 right there. And that's going to tell you that, of course, this is 103. Then what you do is you drag this across so it's in there for a total of 10 cells. And what you've done now is every single cell is going to be equal to the prior cell times 1.03, isn't it? And so each cell tells you, if you're going at 3%, how much is the cash flow going to be each time. Then we use our net present value formula, which we looked at earlier. And we say for net present value, what is the rate? Well, I just referenced cell B1, which was our discount rate there. And then the value is from cells B9 through K9. B9 started right here at 100, and K9 goes out there to $130.47.73 there, okay? So that's going to give us $630.33 as well. So whenever you have a series of cash flows that are growing at the same rate, my suggestion is you do it like this. All you have to do is type in the first one, do a cell reference for the second one, then you just go down here and you drag it out to the number of cells you need, and then you're going to get all the cash flows. Use the net present value formula to find out the present value of all of these, and that's going to give you the answer. Of course, this works well, just as well with the formula there, except that Excel doesn't come with it pre-programmed. you have to actually put the formula together like what I did there into Excel. But that's not difficult, and it's really good practice for you. If you want to be proficient in Excel, you need to be able to write formulas. And like I said, I think the hardest part of writing formulas in Excel is to get the parentheses at the right spots there. So either way, the present value of the growing annuity is $630.33. Well, this marks the end of our material on the time value of money. And please don't think, whew, I'm so glad we got done with that. Now we can move on to something else, because everything in finance is based on the time value of money. It's kind of like the addition and subtraction of mathematics. Okay. What we have done now is we have learned how to take money from one time period and move it to another time period. We've learned how to take a series of cash flows and move them to a different time period. So we can move money around from one time period to another time period, which is fundamental to the understanding and application of finance. So just like in math, if you want to someday be a mechanical engineer, you have to start out with addition and subtraction. You better know addition and subtraction if you want to get multiplication and division. And you better know it if you want to go into algebra. And you better know that if you want to go into calculus, and that if you want to be a mechanical engineer someday. So this is the addition and subtraction in finance. We're going to be using the time value of money to value all sorts of things. We're going to start out learning how to value bonds, because they're the easiest ones. Then we'll learn how to value stock. Then we will learn how to value projects that a company might be considering undertaking. And then we'll see how to value entire companies. So we're going to be using the time value of money we're going to remember the present value of the cash flows is the value of something, right? So we're going to find the value of a bond, then we're going to find the value of stock, then we're going to find the value of projects, and then we're going to find the value of companies, all using the time value of money. So please spend as much time as you need to going over the class notes, going over the looking at the videos, going over the problems that you need to be solving in your textbook and the quiz problems as well, so that you understand this thoroughly. And if you do, the rest of the course will really be a piece of cake. Okay, it's not going to be difficult if you understand this stuff really well. If you struggle with time value of money, I can guarantee you'll be struggling with everything else. So make sure you know this really well before you go on. And we'll see you in the next section.